So I'm Marley Gray. I'm the principal architect for, can't hear me? I don't know how I'm going to talk any louder. They want it louder. I'm talking pretty loud. Okay, so they'll try to work on the sound, but the loud music, I'm not sure how they're doing this anyway. So anyway, I'm on the Azure Blockchain Engineering team, and I'm going to walk you through in 20 minutes what can normally take about 20 hours and talk about blockchain smart contracts. Really what I want to talk to you about is sort of a precursor. There's another session on Friday where I'll spend a lot more time. Friday afternoon, I'll give you the details if you're interested in seeing more detailed information. But this is sort of setting the stage for the new architecture that we're prescribing to start enterprises on their way to building real-world applications. So if you've been following blockchain at all, blockchain's first actual implementation or instance was with Bitcoin, and it was purpose-built for cryptocurrency. And so it had features and functionality that lends itself well to a cryptocurrency or a currency use case, which is actually quite simple. It simply wants to be able to issue assets, track ownership, transfer ownership, and the most important piece at the end is be able to make change. So it's important when you're spending money, if someone is charging you a portion of the money that you hold, and you only hold one, like $1, if you're charging something 35 cents and I give you $1, I need to get 65 cents back. So the first blockchain network was something called a UTXO-based blockchain. It's one of its major features was it could make change. However, most enterprises looked at this technique and saw the ability to take it further. So the natural evolution to currency markets is then to start deriving contracts in which you can base that currency on. So futures contracts. Every industry has them. Financial services is just one that happens to have a lot of these. But if you place an order for a manufacturer to manufacture something, you have that purchase order itself is actually a contract. So the ability to create these things called smart contracts is simply taking that same cryptocurrency use case, but put a cryptographically binding contract on the blockchain that can then execute on its own. So there's lots of different use cases here. This is what largely has created this explosion of interest, particularly in the lines of business and enterprises who say, hey, I want a blockchain, and they have no idea what they really want, and they usually ask us to go figure out how to do that. So first off, what do you need to do to make a smart contract? So there's a lot of different blockchain platforms out there that you can play with. The one that smart contracts are mostly known for is called Ethereum or Ethereum derivative blockchains. But there's other types of blockchains, and they all have different approaches to how they implement smart contracts. So some of the things you have to think about as a developer when you start to approach these things is you'll notice that they're very strange constructs that you don't typically see, particularly in the enterprise, where you'll see lots of cryptographic hashes being used all over the place. The database is not very readable. Everything is put into different types of formats that are hard to work with. The APIs are not well documented. People that are trying to build private blockchains, early on it was very, very difficult just to stand up a private blockchain to play with. The current smart contracts architecture is very immature from a software design standpoint. Now, certain portions of the designs were made in the fact that the first blockchains were designed for public blockchains, which are completely trustless networks, which required you to put your code on the blockchain. So it was in the clear where people could see the code, and they would be able to see the logic that they're agreeing to because they have no idea who's on the other end of that transaction. Where in enterprise or consortium blockchains, where we have a lot of this interest, is where we'll have known parties behind these public-private key pairs. And you don't necessarily need to put all your code on the blockchain. In fact, it's actually better to pull it off for scale reasons. So current versions, they commingle logic and data together, so it's brittle versioning. If you've got a bug in your code, you can't fix your logic without breaking the database. So it's a very brittle difficult to version, and it has no scale story whatsoever. Scaling, typically we look at being able to scale solutions horizontally or vertically, and we typically think about that in tiers. So in the data tier, we often think, oh, we'll scale the data tier vertically. We'll put a big beefy database server in the back end. In the middle tier, we'll scale it out because it's stateless. We'll just throw a whole bunch of middle tier servers in there, and then in the client side, we don't really care at that point. Well, you can't do that with current smart contract platforms. Everything is commingled together, and your smart contract will only execute as fast as the slowest network node in your network, which is pretty pitiful. So what we're proposing is take the current smart contract architecture. So this, I'm going to explain this a little bit here. Down at the bottom, you have the database, which is essentially the ledger. So blockchains are distributed ledgers. They're append-only databases. There is no update or delete function on a blockchain. You have a create and a read. That's just all you have. So you have this ledger this immutable database. Now, smart contracts, when you define them with their properties. So any contract that you go through, you can go pick up a paper-based contract for a car loan, for anything, and it's basically got a lot of legalese, but the essential elements are some basic properties, like how much are you borrowing, what the term of the loan is, what the interest rate is going to be, when the payment is due, if the payment's late, what's the date it's due. So you have these properties. Some of the properties are static, meaning they're immutable. Like when you sign the contract, you're not going to change your signature. You're agreeing to that term. But you also have dynamic properties, like the interest rate. If you have a floating point interest rate where it could change, that dynamic data needs to be able to be reflected in that contract. And then you have your logic. What do you do if the payment's late? What's the penalty? What's the remediation? So contracts that you know from the paper, you can express into very small smart contract programs. And we look at the properties and the logic, and today they're in one deployment package. We're simply saying, hey, let's separate the data and the logic, give us separation of concerns, allow us to put our schema, essentially our properties, defines our schema, and then pull our logic up into something we call a cryptlet. So a cryptlet, the middleware component that is built with the same cryptographic primitives that blockchains are, so it knows how to natively talk to the different blockchain networks, and makes it easier for you to start building applications. So the cryptlet fabric is this framework, which I'll go into much more detail on Friday, that essentially talks about the ability for you to have at the data tier any number of different types of blockchains. So I've got 3 of the most popular categories. There's more in there. Ethereum. There's also enterprise Ethereum version called Quorum that has been released. Chain, Corda, Hyperledger Fabric. There's a whole bunch of them. We're trying to get enterprises to think about the blockchains like they do with their relational database systems or traditional database systems, where they'll pick the database that's right for their functional and non-functional requirements. Things like how much does it cost? So if you build it right, you can move your application from one blockchain platform to the next. And also for our partners that are building solutions for blockchains, we're giving them abstraction layer so they can build their solution, their business solution to sell into the market and be abstracted away from the different blockchains so that you can be portable across and create a marketplace for all different types of blockchain solutions. So the Crypto Fabric provides that abstraction layer in the cloud. We'll talk about the cloud benefits, but blockchain networks are by nature distributed systems, so the nodes can be anywhere in the world. Azure is distributed around the world as well. It becomes a really good place for you to put your business logic to execute these smart contracts. Now, if you think about smart contracts and you start thinking about these business processes that will occur between different counterparties, having the code run on every node doesn't make sense because there's no way for members of a consortium network to accurately gauge how much their transactions are costing because they're running on all the nodes. And it also doesn't make sense to place your logic in, say, one of the counterparty's data centers. There's a trust issue there, where You have one bank going into a trade with a different bank. This bank over here is not necessarily going to trust this bank to run the logic for that smart contract. The Azure provides this secure infrastructure where we're using something called enclaves, which you probably have heard about, where we allow these two counterparties to enter into a smart contract that runs in the cloud and executes in a secure environment, writes its state to the ledger, so they have that shared common truth of the blockchain. But the logic that runs and executes that runs in the cloud, and we can split the check there. We can say, okay, with this certain smart contract with between these two counterparties, you guys are going to split the check for that and be able to actually gauge how much these are costing these, because these distributed systems, once you start rolling them out, you have to think about distributed cost as well. So let's talk about cryptlets. There's two basic categories of cryptlets today that we're designing. The first is what we call a utility cryptlet. A utility cryptlet is a sort of a horizontal, non-contract specific piece of code. Essentially, the primary uses in blockchains for these type of applications are what they call blockchain oracles. So blockchains, because the code runs on every node, you can't have your smart contract that's running on the blockchain. The blockchain node can't go out and grab data to calculate something, because then every node will do the same thing. If that data is volatile, simply the speed of light difference between those nodes, you're not guaranteed to get the same result with everybody going out and reaching out for, say, market data. So you can't, it breaks determinism at that point. So you have to inject data into the blockchains. Well, when you're injecting data between two counterparties that are saying, oh, we're going to have this financial agreement, and the financial agreement, every day we're going to settle, and we're going to settle based on the price of this, oil, some interest rate or whatever. These two counterparties want to make sure that that price that they're determining, the split, is actually from the source that they agreed upon and isn't being spoofed. So we need heavy attestation to this is authentic data. It's coming from the original source. It hasn't been tampered with, to give these counterparties the ability to trust that that data hasn't been tampered with that would affect their smart contract. So utility cryptlets, anybody that's providing information into smart contracts. So if you have financial information that you want to inject in there, we provide a utility cryptlet can do the digital signatures, the secure execution, to create payloads to inject into these smart contracts that have the full attestations that these people are going to require. You can also build your own, and so you can build your own utility cryptlet that might provide your CRM or your ERP system to inject data into the blockchain. You can have utility cryptlets that provide a querying interface, basic rudimentary querying interface into the blockchain. Things that are not specific to contracts. So these are almost anything that you want to do. You can write them. And then contract cryptlets are that second phase where we're pulling that logic of a smart contract out of the smart contract database on the blockchain and putting it in this cryptlet. These guys run in a secure execution environment, so they can run in an enclave. They use digital signatures to attest to their output. They can load, because they're running in enclaves, we can load the identities and sign on behalf of individual users. We can do all sorts of things here with contract cryptlets. So contract cryptlets are really the realization of that new architecture. Let me walk you through how these things work, and then I'll try to get to a demo real quick. So let's talk about multiple cryptlets working together. So in this case, we've moved into where we're the perfect representation of where this architecture would go. On the blockchain node, so this is a node on the blockchain. There could be 1,000 nodes in this network, but the fabric only needs to communicate successfully with one. The fabric is not replicating transactions. We leave that to the blockchain layer. All we're doing is injecting data in a persisting state to the blockchain. So over here, we define our schema, and schema in blockchain languages is different, but it's essentially structs, and you have basic types, and you can create sort of tables and relationships that you want to. And functions operate like stored procedures. So you basically put some logic here. You put your logic up in the contract cryptlet itself, So this guy is running in a container. It's running this logic. This is what we call, this is a swap function, the calculation for a financial swap. Now the cryptlet, this contract cryptlet is actually getting market data from a utility cryptlet, and this utility cryptlet could be coming from a third party. A market data provider could be providing, in this case, the LIBOR rate, which is a bank interest rate, and the price of gold. And what would happen is, a certain time of day, we have an event fire. So we say when the markets are closed, if they were open that day, provide me the price of gold and the LIBOR rate. And so the utility cryptlet will pass that value into the cryptlet itself, the contract cryptlet, which will take those values, calculate those values as inputs into that function, and then write the results securely to the blockchain with these little proof chains. So it has the attestations that these, not only the attestation from the contract cryptlet, but the utility cryptlet is persisted to the ledger. So at any point in time, an audit can take place and somebody can challenge the transaction, and you'll have the cryptographic proofs that everything was on the up and up as it occurred. All right, so let me talk about some of the key points here, and I'm going to jump into the demo. The hard part about this seems like it's kind of rudimentary, but there's lots of things going on under the covers here. You'll see in the demo, there's lots of public-private keys and secrets that are being kept in HSMs or the Azure Key Vault that are securely being transmitted into this enclave, which will be able to sign those with private keys. Again, well, I'll go into much more detail on Friday, but I want to hop in and show you cryptlets in action really quickly. And I'm going to switch over to my Windows device. Sign in real quick. Okay, so what I've got here is I have a Ethereum node on this blockchain network that's running, and it's just sitting there mining. It's not got any transactions coming into it right now. I'm going to fire up the cryptlet fabric. So you can have as many of these as you want to. I'm just going to start up one. This cryptlet fabric has two blockchain oracles or utility cryptlets that are pumping market data into this to smart contracts on this blockchain. One of them is pumping in the price of gold every 10 seconds, and one's the price of oil every 20 seconds or something. And what you're going to see, I'm going to show you the consoles. Normally you won't see the consoles, but for dev audiences, I like to show what's actually going on behind the scenes. So I'm going to go ahead and start this guy up. And there's going to be lots of windows here. I'm going to get the most interesting ones up front. And you can see here's the insertion where they have these two oracles. One's publishing the price of gold and the price of oil and the time in milliseconds that it's occurring. And then it's going to start grabbing these prices. And you can see here's a payload coming from the cryptlet. Again, these are digital signatures. These are attestations, so binary hashes that are coming in, that are flowing in from the cryptlet through the cryptlet fabric. It's getting translated into, in this case, Ethereum. And behind this, so behind these windows, you can start to see these transactions come in. So you'll see these transactions get mined here, and then they'll pop back up here with confirmations, and we'll receive these confirmations as they come in. Now, this is just regular activity that the cryptlet fabric does, is it manages these subscriptions that these utility cryptlets are servicing these different smart contracts, injecting attested data into them. Now, what I'm going to show you is a prototype client. We have several different client experiences. This one allows us to do things like deploy smart contracts, change their bindings, and things like that. So I'm going to try to coordinate this and see if you can actually see what's going on. You can see I have a list of bindings here. I can pick smart contracts out here. I have one here called a total return swap. This is a swap that financial instruments use. I'm going to go up here. I'm just going to go ahead and deploy this package. And it's going to walk me through a wizard. I can go in and put in my reference asset is Microsoft. Now, once it's deploying that, you'll actually see on the blockchain, it actually deploys where it says it created. That's the public address of the smart contract it created. So it created its schema on the blockchain, and it's returning back to the fabric the address that schema is pinned to. Now at that point, I've got the blockchain has been deployed. We're just popping up the different bindings and the block number it was placed into. I have like 13 seconds left, but essentially we allow you to deploy, manage, customize the frequency of these bindings. And on Friday, I'll show you how we actually are exposing it. You'll see a lot more of the code of how you can actually interact directly and build applications on the Cryptlet fabric using .NET, anything in the CLR, the JVM type runtimes that you're used to using, or just using JSON, REST calls, or just plain old AQMS messaging. So you'll get a good feel for the common development patterns that we're bringing to blockchain with the fabric to be able to get and build applications very, very rapidly. And with that, I am out of time, and I thank you guys for coming again. The last session on Friday, it's at 12:30. Here's the time up in 6:08. You can check out our GitHub repos that are up on under our blockchain projects, and check us out. Keep watching. Thank you.